Capacitance when a dielectric is introduced between the plates of the capacitor. Consider a parallel plate capacitor of capacitance C0 with the plate area A each. Plates are separated by distance d apart and plates are charged with Q plus Q on one of the plate having charge density plus sigma and minus Q on the other plate with charge density minus sigma. In between the parallel plates there will be a uniform electric field E0, whereas electric field 0 outside the plates. The system is kept in vacuum medium or free space having absolute permittivity epsilon naught. How to write charge Q in terms of sigma? We know Q is equal to sigma into A. What is electric field E0 in between the plates? That is equal to sigma by epsilon naught. Then what about the potential difference between the two plates? V0 equal to E0 into distance d. E0 is sigma by epsilon naught into distance d. Therefore, capacitance C0 equal to Q by V0, which is equal to sigma A divided by sigma d by epsilon naught. Sigma get cancelled out. Hence, C0 equal to epsilon naught A by d, which is the capacitance of the parallel plate capacitor having plate area A each. Plates are separated by d distance apart and free space or vacuum medium is introduced between the two plates. Now let us see the second case. In the second case, the same capacitor is chosen and the capacitor is filled with a dielectric of constant K. Both the plates are charged with the same charge Q. One plate is plus Q having charge density plus sigma. Other plate is having charge density minus sigma charged with minus Q. Plate area A each. Plates are separated by the distance d apart. So, between the two plates, an electric field E0 exists. But when the area between the plates is filled with dielectric and the dielectric is kept in a field E0, there will be polarization effect in the dielectric. Due to polarization, the charges in the atoms got separated and a plane sheet of charge appear on either end of the dielectric. That is, a plane sheet of positive charge appears in the dielectric near to the negatively charged plate of the capacitor and negative plane sheet of charge in the dielectric is induced near to the positively charged plate of the capacitor. And we know same charge Q exists in the capacitor in this case. Q equal to sigma A as we wrote in the earlier case. But here the net electric field is the vector sum of existing electric field and induced electric field E dashed. Due to this induced plane sheets of charges, an electric field, additional electric field E dashed is produced in the dielectric. And this E dashed is opposite to the existing electric field E naught. Hence, a net electric field appears in between the plates of the capacitor, that is E. E equal to E naught minus E dashed. Or if sigma P is the surface charge density of the charges produced due to the polarization effect, we can write E equal to sigma minus sigma P divided by epsilon naught, or sigma minus sigma P can be represented as sigma by K, that divided by epsilon naught. Somewhere here we'll write sigma minus sigma P is represented as sigma by K, where K is the dielectric constant. Substituting, so here we can write electric field E equal to sigma by K epsilon naught. Now how much is the potential difference across the two plates? Potential difference is E into D. D is the distance between the two plates, or that itself is the thickness of the dielectric. Substituting for E, sigma divided by K epsilon naught into D. So we got the potential difference across the plates. If it is so, we got Q and V, then what is the capacitance C? C equal to Q by V, that is sigma A divided by sigma D by K epsilon naught. Here also sigma get cancel out. Therefore, C equal to K epsilon naught A by D. Already we know epsilon naught A by D is C naught. Therefore, C equal to K times C naught. C is the capacitance when dielectric is introduced between the plates, and C naught is the capacitance when free space is introduced between the plates of the capacitor, or C and C naught are in the ratio C by C naught equal to dielectric constant of the medium, which is placed in the area between the plates of the parallel plate capacitor. Thank you.